So the Renin angiotensin mechanism. Now this mechanism is all about maintaining blood pressure. Okay, so if you are maintaining blood pressure, of course you are going to increase cardiac output, and when cardiac output is increased, definitely the volume of the blood is going to also increase, meaning more water in the plasma and so on and so forth. So here we want to discuss about the Renin angiotensin mechanism. This mechanism is very important in maintaining blood pressure, and of course it is very important for us to know. Good. Now the general overview of this system is that the kidneys, okay, the kidneys are responsible for the production of some hormones, okay, and these hormones are also important in increasing blood pressure, and whenever blood pressure increases, the blood volume also increases. Now whenever blood pressure is down, okay, whenever there is decrease in blood pressure, okay, what happens is that there are some cells, okay, in the kidney, basically in the walls of the afferent arterioles, okay, there are special smooth muscle cells. These cells respond to a decrease in blood pressure. Okay, so whenever blood pressure is decreased, when we were discussing the functions of the kidney, one thing that we spoke about is the kidney. One major function is to maintain blood pressure. Okay, so in the walls of the afferent arterioles of the kidney, what happens is that there are some smooth muscle cells, and what they do is that they respond to a decrease in blood pressure. So if you have our kidney like this, so let us assume this is our kidney. Okay, now when there is decrease in blood pressure, this kidney, the walls of the kidney, which is rich in smooth muscle, the afferent arterioles, they are going to respond by producing an enzyme we called renin. Okay, renin. So decrease in blood pressure causes production of an enzyme we called renin. Okay, so the kidney decrease in blood pressure is going to produce renin. Good. Now whenever renin is being produced, what happens is that, so basically you have to understand that whenever there is a decrease in blood pressure, whenever blood pressure drops, more renin will be produced. Whenever the blood pressure increases, less renin will also be produced. Okay, good. So renin is produced by the kidney in response to decreased blood pressure. Now the aim of this is to maintain blood pressure from the kidney. Now, how does renin regulate blood pressure? Okay, how does renin do that? Now, when renin is produced, circulating the blood, okay, now the liver also produces a protein. Okay, the liver also produces a protein. So let us assume this is the liver. The liver also produces a protein we call angiotensinogen. Now the angiotensinogen produced by the liver is inactive. Okay, when we say something is inactive, meaning that it circulates in the blood doing nothing. Now don't forget I said that when blood pressure reduces, the kidney produces renin. Okay, this renin acts on this angiotensinogen produced by the heart, by the liver. Okay, basically what renin does is that renin creates a sequence of 10 amino acids from the angiotensin. Okay, now whenever renin creates a sequence of 10 protein from the angiotensinogen, it converts the angiotensinogen to its active form. Okay, and the active form of angiotensinogen is called angiotensin 1. Okay, angiotensin 1, which is the active form of angiotensinogen. So angiotensin 1 is the active form of angiotensinogen. Okay, so what is angiotensin 1 going to do? Now the angiotensin 1 will also circulate in the blood. Basically angiotensin 1 is the active form of angiotensinogen, like I said. Now angiotensin 1 will also be converted into angiotensin 2. In this case, here 8 amino acid, okay, 8 amino acid is also going to be craved from the angiotensin 1, giving us what is called angiotensin 2, giving us angiotensin 2. So 8 amino acid is going to be craved from angiotensin 1, giving us angiotensin what? 2. Angiotensin 2 is very important. So angiotensin 2. Now there's an enzyme that converts angiotensin 1 to angiotensin 2, and that enzyme is called angiotensin converting enzyme. Angiotensin converting enzyme. This angiotensin converting enzyme, what it does is that it creates a sequence of 10 amino acids from angiotensin 1 and convert it into angiotensin 2. A lot of people genetically they can't produce this angiotensin converting enzyme, and of course they will face problem in converting angiotensin 1 to angiotensin 2. Okay, and we have drugs that inhibit the activity of angiotensin converting enzyme. Of course, we talk about that later. Now, what is this angiotensin 2 going to do in the body? Okay, now what angiotensin 2 basically does is that it is a potent, so the angiotensin 2 is a potent vasoconstrictor. Okay, so they constrict the vessels, the blood vessels. Okay, so they constrict the peripheral arterioles, and whenever the peripheral arterioles are constricted, okay, it increases peripheral resistance, and whenever peripheral resistance is increased, it increases cardiac output, hence increasing blood pressure. Of course, there is a relation between blood pressure and peripheral resistance, which is so the relation is basically blood pressure equals cardiac output times the peripheral resistance. Okay, so what the angiotensin 2 does is that it causes vasoconstriction in the peripheral arterioles. Whenever the vessels constrict, resistance will increase, and here resistance is directly proportional to the blood pressure. When resistance increases, blood pressure increases, giving us a greater cardiac output, hence increasing blood volume. Okay, so that is what happens in the angiotensin renin system. Now, another function of angiotensin 2 is that it has ability, okay, to cause the release of aldosterone, 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 aldosterone from the body. Okay, so what happens is that when angiotensin 2 is released, it acts on the adrenal gland. Okay, there are a lot of hormones produced by the adrenal glands, the mineralocorticoids, the cortisol, those type of enzyme, and among them is what? The aldosterone. The angiotensin 2 here acts on the adrenal gland to produce aldosterone. Okay, aldosterone. Now what aldosterone does is that it increases the amount of sodium absorption. Okay, so aldosterone increases the amount of sodium absorption. So in the presence of aldosterone, absorption of sodium increases, and whenever the absorption of sodium increases, what happens is that this sodium will cause increase in intravascular volume. Okay, now whenever the volume of the blood vessels increases, it leads to increased venous return. Whenever there is increase in venous return, there is increase in blood volume because cardiac output increases. Okay, so aldosterone is very important when it comes to the maintenance of blood pressure. So what I did today is that I was giving the general overview of the renin angiotensin mechanism, where I said that whenever blood pressure drops, the kidneys respond by producing renin. This renin is a hormone produced by the kidney, circulate in the blood. Okay, when renin circulates in the blood, at a certain point in time, the liver also produces angiotensinogen. Angiotensinogen. This angiotensinogen is a protein produced by the kidney, which is in inactive, circulate in the blood just like that, circulate in the blood. So what happens is that the renin produced by the kidney will act on the angiotensinogen, convert it into angiotensin 1 by creeping a sequence of 10 amino acids from the angiotensinogen. We get angiotensin 1. Angiotensin 1 also is being converted into angiotensin 2 by angiotensin converting enzyme. This angiotensin 2 causes vasoconstriction. Okay, the peripheral arterioles constrict, and when they constrict, resistance increases. Whenever resistance increases, increases blood pressure. Blood pressure increases, cardiac output also increases. Cardiac output increases, blood volume increases. Water volume increases in the plasma. Angiotensin 2 also have an effect on the adrenal glands by producing aldosterone, a hormone, which causes increase in absorption of sodium level. Sodium causes more water to be absorbed, increases cardiac output, increases blood volume.